Today, we're going to be taking a look at how we can use LangGraph to build more advanced agents. Specifically, we're going to be focusing on the LangGraph that is compatible with the v2 of LangChain. So it's all the most recent methods and ways of doing things in the library. And we're going to be building a research agent, which gives us a bit more complexity in the agentic graph that we're going to be building. Now, when I say research agent, what I am referring to is essentially these multi-step AI agents, similar to, like a conversational React agent, but rather than aiming to provide fast sort of back and forth conversation, they aim to provide more in-depth, detailed responses to a user. So in most cases, what we would find is that people don't mind a research agent taking a little bit longer to respond if that means that it is going to reference multiple sources and provide all of this well-researched information back to us. So we can afford to wait a few extra seconds. And because we have less time pressure with these research agents, that also means that we can design them to work through multiple research steps where it's referencing these different sources. And it can also go through those different sources multiple times. It can do a Google search, it can reference arXiv papers, and it can keep doing that, and so on and so on. Now, at the same time, we might also want to make our research agent conversational. So we would still, in many cases, want to allow a user to chat with the research agent. So as part of the graph that we're going to build for the research agent, we also want, just something simple where it can respond. Okay, so let's start by taking a quick look at the graph that we're going to be building. So we have obviously the start of the graph over here, which is where we start. And this goes down into what we call the oracle down here. Now, the oracle is like our decision maker. It's an LLM with a prompt and with access to each of these different nodes that you can see. So the RAG search filter, RAG search, fetch archive, web search, and final answer. So the oracle can decide, okay, given the user's query, which comes in from up here, what should I do? Okay, so for example, if I say something like, hello, how are you? Hopefully what it will do is it will go over to the final answer over here, and we're going to just provide an answer and end the execution of the graph. But if I ask something that requires a little more detail, for example, I ask about a particular LLM, what we might want to do first is, okay, we do a web search, find out about the LLM. That will return information to the oracle, and the oracle will decide, okay, do I have enough information here, or is there anything in these results that are particularly interesting? Like, for example, is there an arXiv paper mentioned in these Google results? If so, it might just decide to give us an answer straight away, or it might decide, oh, okay, let's go and refer to our arXiv papers database, which we do have within the RAG components, so one of these two. And we also can fetch the arXiv paper directly, but this is just a summary. So we could refer to any of these. So maybe it wants to have a look at the summary. Okay, so it has a look at the summary. It says, okay, this is relevant, cool. Now what I'm going to do is I'm going to refer to my RAG search with a filter. Okay, so the filter that it has here allows it to filter for a specific paper. And that might return, all of the information it needs. And then at that point, it would come over to our final answer and basically build us this little research report and submit everything to us. So that's what we're building. There are a fair few steps here and a fair few nodes that we need to build in order for all of this to work. But before we do jump into actually building that graph, I wanted to talk a little bit more about graphs for agents and just LangGraph at a higher level. So using almost like a graph-based approach to building agents is relatively new, or at least I haven't seen it for a very long time. And what we had before was just more like, okay, we have this way of executing agents, or we have this way. And the most popular of those sort of agent execution frameworks that we've seen is called React. Now, what React does is it encourages an LLM to break down its generation steps into these iterative reasoning and action steps. The reasoning step encourages the LLM to outline the steps it should take in order to fulfill some objective. And that is what you can see with the thought steps here. And then the action or acting steps are where the LLM will call a particular tool or function, as we can see with the act steps here. Okay, so when that tool is called, so for example, here we have the search Apple remote, we of course return some observation from that, which is what we're getting here. And that is fed back into the LLM. So it now has more information. And that is very typical, okay? That sort of React framework has been around for a long, or at least a fairly long time, and has by and large been the most popular of agent types. And this agent type, in some form or another, found its way into most of the popular libraries. So LangChain, Llama Index, Haystack, they all ended up with React or React-like agents. Now, the way that most of those frameworks implemented React is with this object-oriented approach, which is nice because it just kind of works very easily, and you just plug in a few parameters, like you plug in your system prompt, you plug in some tools, and it can just go. But it doesn't leave much in the way of flexibility, and also just for us to understand what is actually going on, we're not really doing anything. We're just defining an object in one of these frameworks, and then the rest is done for us. So it means that we miss out on a lot of the logic that is going on behind the scenes, and makes it very hard to adjust that for our own particular use cases. And an interesting solution to that problem is to, rather than building agents in this object-oriented approach, to instead view agents as graphs. So even the React agent, we can represent it as a graph, which is what we're doing here. So in this React-like agent graph, we have our input from the user up at the top. That goes into our LLM, right? Then we are asking the LLM to kind of reason and act in the same step here. It's React-like, it's not necessarily React. And what it is doing is saying, okay, I have this input and I have these tools available to me, which is either tool A, tool B, or a final answer output. Which of those should I use in order to produce an answer? So maybe it needs to use tool A, so it would go down, generate the action to use tool A, and we would return an observation back to the LLM. Then it can go ahead, it can maybe use another tool again, right? It could use tool B, get more information, and then it can say, okay, I'm done now. I will go through to my final answer and return the output to the user. So, that's just a React-like agent built as a graph. And when you really look at it, it's not all that different from the research agent that we're building. Again, it's similar in some ways to a React agent, but we just have far more flexibility in what we're doing here. So, if we really wanted, we could add another step, or we could modify this graph. We could say, okay, if you do a web search, you always, after doing a web search, must do a rec search. And then only after doing that, you can come back to the Oracle, right? We could do things to modify that graph, make it far more specific to our use case, and we can also just see what is going on. So for that reason, I really like the graph-based approach to building agents. I think it is probably the way to go when you need something more custom, you need transparency, and you just want that degree of control over what you're doing. So that brings us over to LangGraph. So LangGraph is from LangChain, and the whole point of LangGraph is to allow you to build agents as graphs. Okay. As far as I'm aware, it's the most popular of the frameworks that are built for graph-based agents, and it allows us to get far more fine-grained control over what we are building. So let's just at a very high level have a quick look at a few different components that we would find in LangGraph. Now, to understand LangGraph and of course just build our agent as well, I'm going to be going through this notebook here. You can find a link to this notebook in either the description of the video, or I will leave a link in the comments below as well. So getting started, we will just need to install a few prerequisites. So I'm going to go ahead and do that. So we have this install GraphViz, libGraphViz. Basically all of the things that we need here are just so we can visualize the graph that we're going to be building. You don't need to install these if you're just building stuff with LangGraph. It's purely if you want to see the graph that you're building, which I think is, to be fair, very useful when you are developing something, just so you can understand what you've actually built, because sometimes it's not that clear from the code. So visualizing things helps a ton. Now, there are quite a few Python libraries that we're going to be using here because we're doing a lot of stuff. So we're going to go ahead and install those. We have Hugging Face datasets, obviously, for the data that we're going to be putting into the RAG components. We have Pinecone for the RAG components, OpenAI, the LLM, of course, just LangChain in general. Note that we are using V2 of LangChain here. We have LangGraph, Semantic Router for the encoders, SerpAPI for the Google Search API, same here. And then PyGraphViz for visualizing the agent graph. Now, before we start building different components, I will just very high level, again, go through what each of these components is actually going to do. So we have the arXiv paper fetch component here. So what this is going to do is, given an arXiv paper ID, it is going to return the abstract of that paper to our LLM. Web search over here is going to provide our LLM with access to Google Search for more sort of general purpose queries. We have the RAG search component here. So we're going to be constructing a knowledge base containing AI arXiv papers. And this tool is the access route for our LLM to this information. And also very similar is the RAG search with filter component. And this is exactly the same. It is accessing the same knowledge base, but it also adds a filter parameter so that, for example, in the web search, if the agent finds a arXiv ID that it would like to filter for, it can do so with this tool. Then finally, we also have the final answer component over here. So this is basically a custom format for our final answer. And that custom format looks like this. So it is going to output a introduction, research steps, report, conclusion, and any sources that the agent used. And it will output all of this in a JSON format. And we just simply reformat that into the format, this sort of plain text format after the fact. So we're going to set up the knowledge base first. To do that, we're going to use Pinecone and also this AI arXiv 2 chunks dataset. So it's basically a pre-built, pre-chunked dataset of AI arXiv papers. Take a moment to download. And what you're going to see in there is stuff like this. So this is actually, I think it's the authors and the abstract of the Mixture of Experts paper. This is all being constructed using semantic chunking. So yeah, you'll basically, the chunks that you'll see, they vary in size, but they, for the most part, should be relatively concise in what they are talking about, which is ideally what we want with chunks. So first thing we'll need to do is build our knowledge base. For that, we need the embedding model. So we're going to be using OpenAI's text embedding 3 small. So you will need an OpenAI API key, which you would get from here. We enter. And then we also get a Pinecone API key as well. Okay, so we've entered that. Now we are going to be connecting to, I think US East 1 is the free region. So you should use that. And what we're going to do is just create a new index. So to create an index, we do need dimensionalities from our encoder. So we get that, 1536, and then we create this index. Okay, so dimensionalities with the index name, you can make that whatever you like. The metric should be cosine or dot product. I think you might also be able to use Euclidean with embed 3, and then we're just specifying that we'd like to use serverless here. So we run all of that. I already have this index created. So, well, you can see that here. Basically, I already have, like the vectors are in there, 10,000. And yeah, that's already created. So the 10,000 that I have here comes from here. So you can index the full data set, but I think it's 200,000 records, which will just take a little bit of time. Again, you can, it's up to you, but it's time, also the cost of embedding. So it's up to you, but 10,000 is fine for this example. So you just need to run this. I'm not going to rerun it because I already have my records in there. And with that, our knowledge base is ready, and we can just move on to all of the graph stuff. So the first thing is the graph state. Now, at the core of a graph in LangGraph is the agent state. The state is a mutable object that we use to track the current state of the agent execution as we pass through the graph. We can include different parameters within this agent state, but in our example, I want to be very minimal and just include what we really need for this example. So in here we have the input, which is actually the input from the user. We have the chat history. So, if we do want to have this as more of a conversational research agent, we have the chat history in there. And intermediate steps, which is where I'm going to be tracking what is going on within the graph. So we have all of that. I say probably the main confusing thing here would be this operator add thing here and how we are constructing the intermediate steps. So essentially, this operator add tells LangGraph, or the graph within LangGraph, that when we are passing things back to the intermediate steps parameter of our state, we don't replace intermediate steps with the new information. We actually add that information to a list. Okay, so it's probably the main slightly different thing to be aware of there. Now we're going to go ahead and start building our custom tools. So as I mentioned before, we have those different components. First of those is relatively straightforward, so we'll build that first. We have the arXiv paper fetch. So the fetch arXiv tool is where we, given a arXiv ID, we're going to return the abstract for that paper. And all we do is we import requests. We're going to test it with the mixture paper here. And all we really need is this, okay? So we're just sending a GET request to the export.archive site, and we pass in the arXiv ID. And when we do that, we should get something like this. Now, this isn't everything. Let me expand this. It's relatively big. You see there's quite a lot going on there. So what we need to do is within this mess, we need to extract what we actually want, which is the abstract, which is somewhere in here. I'm not entirely sure where, but we can extract that with this regex here. Okay, so we use that, and there we go. That's our abstract. So relatively straightforward tool. It just takes in the arXiv ID, and we're going to get the abstract for a paper. Now, the way that LangGraph works is that it expects all of this to be built into a tool, which is essentially a function like this, which consumes a particular value, which is the arXiv ID in this case, and it is decorated with the tool decorator from LangChain. We specify the name of our tool here, which is I'm keeping things simple. We're using the same name for the tool as we use as for the name of the function. So I'm going to run that. And with that, our tool is ready and we can test it. So to run any tool, we have to run invoke, then we pass input, and to input, we pass a dictionary, which must align with the parameters that we've set for that particular function. So we do that. The next component that we want to be using is web search. So web search, we're going to be using the SerpAPI. And for that, again, we do actually need an API key. So to get that API key, I don't remember exactly where it is. I'll give you the link. Okay, so you'll need to create an account and go to here. So serpapi.com/manage API key. Then you'll get an API key and just enter it in here. Okay, so basically we do a search like this. So we have a query, we're querying for coffee here, and we'll get all of our results in a dictionary here. Now, what we do want to do here is restructure this into a string that is a bit more readable. So that's what I'm doing here, and let's see what we get. So using that, we're going to get something like this. All right, cool. So we have that, and again, we're going to put all that into a tool. One thing that I didn't mention before is that we also use the doc string in our tool to provide a description to our LLM of, when to use the tool, how to use the tool, and so on. So same thing, we initialize that. Now, the rag tools, we have two of them. We have just the rag search, and we also have the rag search with a filter. So let's go through that. We are going to actually come to that in a moment. We'll create the tools first. So to create the tool, I have a query. This is the filter one. So we have query, which is a natural language string. And we also have the arXiv ID that we'd like to filter for. All we do is we encode the query to create a query vector. We query. We include our filter. So we have that here. And then from that, we're going to use this format rag context to format the responses into, again, another string. Okay, so you see that here. So title, content, arXiv ID, and any related papers to that, what we return. We also have the same here. We have rag search, and it does the exact same thing, but it just doesn't have the arXiv ID filter. And it also returns fewer top K here. I'm not actually sure why I did that, but yeah, I'm going to keep it. But you can adjust those if you'd like to return more stuff, you can. But yeah, we have that. So finally, we have the final answer, which is, the way that I've done it here is basically another tool. And the reason that I've set it up as a tool is because we have this particular structure that I want our LLM to output everything in. We're also using the doc string here to describe a little bit of what we want for all of this. So yeah, we have all of that. But yeah, that's it. So we construct that. And actually this bit here isn't even used. So you can just remove that. It doesn't matter. I'm returning nothing here. And the reason I'm returning nothing is because we're actually going to return what the LLM generates to use this tool out of our graph. Okay, and then we have another function, you'll see in a moment, that will take that structure and reformat it as we would like it. We could also do that restructuring in here and just return a string, but I've just left it outside the graph for now. Okay, so that is all of our components. So we have covered basically all of these here. They're all done. Next, let's take a look at the Oracle, which is the main decision maker in our graph. Oracle is built from a few main components. Okay, so we have obviously LLM, the prompt, which you can see here, and of course, just binding that LLM to all of our tools and then putting that all together. So there's a few parts we'll go through very quickly here. The first is, yes, the prompt. So we are using LangChain's, prompting system here. So we're using the chat prompt template. We also include these messages placeholder because that's where we're going to be putting in our chat history. And we're also going to add in a few other variables as well. So we have system prompt and chat history, followed by our most recent user input, which comes in here. And then we follow that up with the scratchpad. Now, the scratchpad is essentially where we're going to be putting all the intermediate steps for our agent. So yeah, you can imagine, okay, you have your system prompt, you have the chat history, you have the most recent interaction from the user, and then following that, we're going to be adding assistant messages that are saying, okay, I'm going to go do this search, I've got this information, so on and so on. So yeah, that is our prompt. Then we want to set up our LLM. Now the LLM, we're just using GPT-4o here. There's nothing special going on there, but the one thing that is important, if I come down to, I need to import something quickly. Let's rerun that. Okay, so the part of this that is important is we have this tool choice option here. And what that tool choice any is doing is essentially telling our LLM that we have to use a tool, right? Because otherwise the LLM may use a tool, okay? It may use one of the components, or it may just generate some text. And we don't want it to be generating text. We want it to always be using a tool. And the reason for that is even if it does just want to respond, it has to go through the final answer tool to respond. So we're just forcing it to always use a tool. So that is what our tool choice any does here. And we can go through the rest of this quickly as well. So we have, yes, the LM, the tools. The scratchpad here is basically looking at all of the intermediate steps that we've been taking and reformatting them into a string here. So we can see the name of the tool that was used, the input to that tool, and the result of that tool. Okay, so the output from that tool. And we just put all of that together into the string, which goes into that agent scratchpad section. So this bit here. And then here we're using the LangChain expression language to basically put everything together. So our Oracle consists of these input parameters. We have input, chat history, and scratchpad. These are all fed into our prompt. Okay, so the prompt, if I come to here, you can see that we have chat history, input, and scratchpad, the exact same parameters that we're using here. So they need to align. So yep, they populate our prompt, and then the prompt is passed over to our LLM, which also has access to the tools that we have defined here. Okay, and that's it. So that's our Oracle. Now we can test it very quickly to just confirm that it works. So we run this. Okay, and we basically get a ton of output here. And this is the output that we're getting from our model. Okay. So the output, the AI message, which is actually just empty, because what we really want here is we want to see what the Oracle is deciding to use. So we can go here, right? You can see the name is RAG search. So it's deciding to use the RAG search tool here. We are not training this to give us facts about dogs, so it's not perfect usage. But anyway, we have the reg search tool, and the query, so the input query is interesting facts about dogs. And it's going to go and search for that. Okay. There we go. And you can keep rerunning that and seeing what it comes out with. It will probably vary every now and again because there is, of course, some degree of randomness in there. Now, our agent, the Oracle, is going to be outputting a decision to use a tool. So when it outputs that decision to use a tool, we want to be having a look at what it is output and saying, okay, it wants to use the reg search tool. Let's go and execute the reg search tool. It wants to go use the web search tool. We go and execute that. So that is what our router will be doing. So that is what we can see down here. Okay. So the router is literally consuming the state. It's looking at the most recent intermediate step, which will have been output by our run Oracle function here. Right, you can see that it returns the intermediate steps, which is the action out. And we're just going to be returning the name of the tool that we got from the Oracle. So we'd run that. We don't need these extra cells. And with that, the only remaining thing that we need to, turn into a function, and which we will use to add to our graph in a moment, is the run tool function. Now, the run tool function, we could split all of our tools into multiple functions, kind of like how we have our own function for the run Oracle here. But all of these tools can be executed using the same bit of code. So there's no real reason to do that. So instead, I just define a single function that will handle all of those tools. So again, that's taking the state, looking at the most recent intermediate step. We look at the tool name and the tool input, which has been generated by our Oracle. I'm going to print this out so that we can see what is actually happening when this is running. And then we would here, tool string to function is just this dictionary here. This is basically going to take the tool name, map it to a function, and then we're going to invoke it with the input that we have from here. So we run all of that, then we create this agent action object, which basically is just a way of us describing having a object that describes what happened or what tool we use, what the inputs to that tool were, and the observation, i.e. the log that we got back from it. And then after that is done, we pass all of that information back to our intermediate steps. So we run that, and now we can define our graph. So we have all the components there, they're all ready. Now it's time to define the graph. So for the graph, we already have the agent state that we've defined. So we actually need the agent state to initialize our graph. So we use a stateGraph object. And then once we have our initialized graph, that graph is empty, right? It doesn't know, all the stuff we've just done or the components we defined. So we need to then tell it which components we have defined and start adding all of those. So we do that using the graph add node method. And what we're going to do is just take our string and we're going to map it to the function that would run that tool. Okay. So, or run that tool or run that component. Okay. So for Oracle, we would be hitting the run Oracle function. For these ones here, so reg search filter, reg search, so on and so on, as I mentioned before, they can all be executed using the exact same bit of code. So that's exactly what we do here. We just pass in the run tool function. So we do that, we define all of our nodes there. Then the next step is to define, okay, which one of those nodes is our entry point? Where does the graph start? Okay. And that is, of course, our Oracle, right? We saw the graph earlier here. So we're always starting, okay, we start with the start where we input our query, and that goes directly to the Oracle. So in reality, the Oracle is our entry point. Okay. Then we have following our Oracle, we don't just have one direction to go. We have many different directions. And the way that we set that up is we use our router and we have what are called conditional edges, which are basically these dotted lines here. So we add those conditional edges. The source for where we're starting from there is our oracle. And the thing that decides which path we should take is our router. So our oracle outputs the tool name and our router basically passes that tool name and then directs us in whichever direction we should go. Then we need to add edges from our tools back to the oracle. So if you see on here, we have these, the full lines here. That's basically saying, okay, if we are at one of these tools, we need to go back to the oracle. Like it can't go anywhere else. So it's not a conditional edge. It isn't dotted. It is a normal edge, i.e., when you're at this component, this is where you're going next. And all of these components, except from final answer, go back to the oracle. And that is what we have defined here. So we say for tool object in tools, if it is not the final answer, we're going to add an edge from the tool name or the tool object dot name back to the oracle. That's what we do. And then finally, we have the final edge, which goes from our final answer to the end node, which is exactly what you can see from here all the way over to our end node there. Okay, and that is the definition of our graph. We can just confirm that it looks about right, which we do here. Okay, actually the oracle has a conditional edge over to the end. I'm not sure why that is. But for the most part, this is what we're looking for. So we can stick with that. And yeah, everything is compiled. We can see the graph. Looks about right. And yeah, we just go ahead and try it out now. So let's see what that looks like. We'll go to the first question. Again, not on topic for our AI researcher, but we'll just try it. So tell me something interesting about dogs. Let's run that. Okay, and we can see all the steps that are, being processed, and that is because I have put a load of print statements in throughout the code. So we can see that it's hitting the oracle, it's going to the RAG search, and it's invoking this query, interesting facts about dogs, right? It's probably not finding much. So then it's going to the web search. Well, actually, sorry, it goes back to the run oracle, then it goes to web search, performs the same. And at this point, it probably has some interesting information. So we go back to the oracle and the oracle says, okay, we have the information. Let's go and invoke the final answer. And then the final answer, as you can see, right, we have this introduction. And we'll go through, so on and so on. We have the research steps. And basically, we have all like that full format that I mentioned before. So with that full format, I'm going to define a function that will build the report and just format it into a nicer, more easy to read format. So that is within this build report. It's going to consume the output from our graph, and it's going to restructure everything into this here. So let's see what it came up with for the first question. Okay, so we can see there's quite a bit in there, given the question as well. So introduction, dogs are fascinating creatures that have been companions to humans for thousands of years, so on and so on. It's a real introduction. The research steps that were performed. So it actually says, okay, I went to arXiv for academic papers or research related to interesting facts about dogs. Then it performed a web search to gather general knowledge and fun facts about dogs from various reputable sources. Then it gives you the little report here, which is, I think, looks pretty good. And then we have a little conclusion. Finally, we have our sources, okay? So we can actually see from the sources, they didn't really rely so much on the arXiv papers, which is not surprising given that they are AI arXiv papers. But we can see most of these are, I assume all of these are actually coming from the web search tool. So yeah, that is our first little research report. Let's try something a little more on topic, although still quite general and broad. We're going to ask it to tell us about AI. So let's run this. So it goes with RAG search first. The query is just AI. Then we go back to the Oracle. Then we have web search. Then back to the Oracle again. We have RAG search filter. So it's really, it's going for it here. So it's looking at this paper, which I assume is gotten from the references of the previous, probably from the web search SEP, or maybe even the RAG search SEP as well. So, yep, it's going for this arXiv paper. Then we're going for another arXiv paper here. And finally, we have our final answer. So there's a lot of information coming in from here. So let's see what we get there. All right, nice. So we have a nice little introduction, the 3 steps it performs. So it's specialist search on AI using the arXiv database, a web search to gather general information, and then filtered specific arXiv papers to extract detailed insights on AI-related topics. Cool. Now we have the report. So I'm not going to go through all of that, but just at high level, looks kind of relevant, so nice. It has some like recent stuff in here, GPT-4. We have ChatGPT and Pi 3 in there, so it's getting some relatively recent information. Then we have the sources. So this is probably the most interesting bit to me. So, what have we got here? So an in-depth survey of large language model-based AI agents. Seems pretty relevant. And cognitive architectures for language agents. Another kind of interesting sounding paper. We have the Wikipedia page for AI and Google Cloud. What is AI? So yeah, some, I think, good sources there. Let's try one more. So we'll get a lot more specific on this one. So I want to ask, what is RAG? Let's see what we get. So we are running the Oracle. It goes to RAG search, asking about RAG. We go back to the Oracle. Then we have web search, again, asking about RAG. It goes back to the Oracle again. And from there, it's like, okay, final answer. So it seems to have had enough with that. Let's see what we get. Nice. Okay. So RAG is an advanced technique in the field of AI, integrating external knowledge sources. Cool. Research steps, specialized search using the RAG search tool. Perform the web search to obtain general knowledge and additional perspectives on RAG from various sources. Compiled and synthesized the information to provide a comprehensive understanding of RAG. We have the little report here. It looks reasonable. 2 main components, retriever and generator. Nice. And yes, addressing the limitations of traditional LLMs, so on and so on. And then we have all of these sources here. So we have from AutoGen, Simply Retrieve, AWS, NVIDIA, Google Cloud, and IBM. Okay. So the AutoGen here is that, and both of these seem to be the arXiv papers that they found. And then the rest of these are, I assume, from the web search. So that looks pretty good. So you can already see that, LangGraph was pretty nice in allowing us to build a relatively complex agent structure. And it was, or at least in my opinion, far more transparent in what you're building. Like, we know what prompts are where, we know what tools we're using, and we can modify the order and the structure of, when and where we are using those tools, which is nice to have, and something that is kind of hidden away when you're using, the more typical or the past approach of like React agents as objects or classes in Python. And yeah, we've seen how that all goes together quite nicely to build a research agent, which, from what we've seen, like, given we didn't really work much on tweaking it, it worked pretty well. Like, it was going to different sources, it was doing like the web search, the RAG search, and then like going through and filtering for specific papers to get more information. And that was with just a few quick tries. So it's hard to say how it would perform used with a broader set of questions, but just from those quick experiments, that seems pretty cool in my opinion. Now, I think this sort of approach to pairing both graphs and agents is just nice for all the reasons I just mentioned. It works well. And it's not just LangGraph that does it. I mean, LangGraph is probably the best known library, but I'm also aware that Haystack have something in there at least. And I believe Llama Index either have, or they might be putting something together. I'm not sure, but I've heard something about Llama Index in that space as well. So they're probably things I'll look into in the future. But for now, I'm going to leave it with LangGraph and this research agent. So yeah, I hope all this has been useful and interesting. Thank you very much for watching, and I will see you again in the next one. Bye.